Hi, in this video I will show you how to test or repair inverter welders. I just bought one faulty from eBay. We're gonna try to repair it. I will show you some tips because most of the inverter welders looks very similar. So let's start. Before we do anything, before we blow anything, we have to check if there is no shortage. The first thing, we're just taking the multimeter, we're setting the multimeter on continuity and ohms, and then we're checking continuity between neutral and live. Right, we have about 147 ohms. That's much too low. So that's mean there's a short circuit. So we cannot plug in because that's gonna blow our fuses. In my case, because I'm using the isolating transformer, I can connect even the faulty welder with the short circuit to my transformer, and I will show you what's gonna happen. So all the wires connected with my standard 13 amp plug. Let's plug in, make this safe, and we will see what's gonna happen. So I'm gonna start the socket just for a second to see the amperage and watch the voltage as well. Right, so what's going on? The voltage goes down, is going so low that actually it's not enough to supply the display. The amperage goes up, and this is actually the maximum what I can get from my isolating transformer. Absolutely don't do this at home on your normal sockets on the walls. I can do this only because I've got the isolating transformer. So that's why you should use the isolating transformers for testing any device what you want to repair. In this case, we're gonna just open the welder and see what is inside. So we have the welder without cover now. The first thing what you must do every time when the welder was connected to mains, you have to discharge the capacitors. There's a few big capacitors inside there. They're here. That's the big capacitors. On the other side, they're connected here. Here. There's 6 of them. So I'm using the 47 ohm 10 watt resistor to discharge the capacitors. Basically, you're just shorting the pins on the capacitors. Just be careful, always using glasses, because you can create some sparks. And if you're gonna just discharge the capacitor straight after you disconnect the welder from the mains, there will be still a lot of voltage there. So it's better to wait about a minute before you do this, because there is some resistors already built on the PCB here and here to slowly discharge the capacitors. They're about 100 kilo ohms, so it will take a few minutes to discharge completely the capacitors, but it will happen by itself. But just in case, always check with the extra resistor or with your multimeter. So because there is a shortage on the power supply, I suspect something is wrong just on the beginning of the circuit. So from the 230 volts power supply, there's only few things. There's few filtering capacitors and a few inductors and nothing else actually, and the wires goes to the rectifying diodes. So let's see what actually visually we can check on this side, and then we may find the fault. Okay, what I found on the supply section, the heat shrink tube is gone. On the varistor, the blue thing, and you can see it's just exploded. This thing here, the varistor is here for overcurrent. So basically, if the high current will flow through the wires, the varistor will make a shortage to blow the fuse. From here, the wire is going to the rectifying diode. So there is a big chance that the rectifying diode, what is here, that the rectifying diode is gone. I will take it out and we will see. Let's unscrew the diode, actually the bridge, rectifying bridge. It looks like this. I'm quite surprised that there's only one, because it's quite a big welder. So, by the way, let's clean it and just test it. There's 4 diodes, 4 single diodes inside. It's quite easy to check it, to test it. Again, put your tester on the diode, and then you have 3 pins with the same direction, and there's one with the opposite direction. The one with the opposite direction is a plus on the rectified side. Across this pin, this is a minus. So this 2, that's the supply of the AC voltage, and this 2, that's output of the DC voltage, where this one is plus. So if we know this, we can test the individual diodes between these pins. So if this is a plus, the voltage must go from the AC side to plus. So if you're gonna stick the black probe, the minus probe on this pin, and then the positive red probe on the AC side, we can see it's almost half of volt. This is the voltage drop on the diode, so that means the diode is alright. The same from the other side, from the AC to plus, that's almost half volt. That's okay. Just in case, we can test it from the other side, but this diode looks alright. It should be absolutely nothing from the other side. That's good. And that's good. And again, we can do the same thing with the minus, so we can test the other 2 diodes. But in this case, we're gonna put the minus on this side. Oh, sorry, the red on this side, and then the black from the AC sides. That's half volt and half volt. And we can do the other test. Nothing and nothing. Right. So the rectifying bridge, it looks alright. So where is the problem? Is it if it's only the varistor what is making the shortage? Let's see. Let's change the settings on ohms, and then let's put the welder back down. And if we're gonna test the varistor only, right? So we have 135 ohms. That's much too low. This is shortage. Right, so let's take the varistor out, and we will see if it's something else causing the problem. So this is the explode varistor. We probably can read some marks on it. We'll see if now the shortage will disappear. So we're gonna put the probes on the neutral and the live. Right, and we have something like 102 kilo ohms. So this is not the shortage anymore. That's probably these two resistors. This is only to discharge the capacitor, so that's absolutely fine. So I think we can connect the rectifying bridge, and we can start the welder without a varistor, just for test. Of course, the varistor is for safety. If something goes wrong, the varistor will make a shortage. In this case, because there is no fuse on the way, it was probably blowing the fuse on the previous owner installation, and probably that was the reason why he sold the welder, was just stripping the whole electric. Right, everything connected back. Let's plug it in to our isolated socket and just turn around. So we will see if any lights will come on. Right. Ready? Whoa! There you go. So we have a working welder. Of course, it needed to be tested. I will just plug some cables, some leads here, and I will test it. But for now, we can just check if there's any voltage here on the output. This is a DC welder, so if we're gonna just stick the probes here, there you go. We have a 56 volts, almost 57. That's absolutely fine. So that's the voltage what we're just looking for. So it looks like the welder is working fine now. What we need to do, we need to get the new varistor welded back on, soldered back on, and the welder is fixed. Okay, before we do anything, because I had my welder connected to the mains, I will discharge the capacitors again. The welder was off for a few minutes, so I don't expect any voltage on the capacitors. Right, so I will quickly explain how the welder works. Probably I will do on the other videos, because there was so quick repair. Then we can spend some more time to see how it works. Right. Alright, let's see the wiring schematic. This is actually from different welder, but as I said on the beginning, most of the welders are very similar. So definitely the supply circuit will be almost same. So this is our power supply, 230 volts. Then there is some capacitors and inductor. Of course there is a discharge resistors connected in series, and this is our varistor. So this is the faulty part, and actually that ends, the supply circuit ends on the bridge rectifier. From here we have a DC voltage. So how the welder works, after this point we get in about 330 volts DC. So I will show you step by step this on the welder in a second. Here's the relay to connect the supply voltage. Then we have the big capacitors here. In our case there is 6 capacitors, and they're connected in series. So this is the half bridge configuration. This is too much to explain, but basically what's happening, we have two transistors connected in series. The control board, what actually is just controlling this gate here, is switching the transistors one by one. So when this one is on, this one is off, and the opposite way. So basically what's happening, on the main transformer, well, that's the biggest transformer on the welder. On the big transformer, on one side we have on the primary winding we have a plus and a minus, plus and minus all the time with the frequency about 50-60 kilohertz. So after the transformer we have the secondary winding, and basically on this case we have two secondary windings, and the minus out, and then we have one winding going through the diodes, out and through the diodes, and is going to the same point. So that's our plus on the welder, and that's actually the welding leads. Of course we have some control board here. The board is connected to fan, is connected to some chips to control the transistors. Of course there is some controlling boards on the front of the welder, so potentiometer, some switches, diodes, and so. Of course there is not everything on this schematic, but this is the most important parts actually. So this is the power supply, the main switch, the two filtering capacitors, inductor, here is the varistor, that's the wires going to bridge rectifier. We have the auxiliary transformer. There is the chip to control the to run actually the transformer, and some power supply wires to the control board. The whole thing does the control board, and of course some wires coming out, and that's probably connected straight with the driving transformer. This is between control board and transistors, basically to isolate the transistors from the control board. Very sensitive board basically. The transistors are right there. It's on the radiator. There is 4 of them. One here, second, third, and fourth. From the other side of the PC board, they're located here. Here's the one. That's the 3 legs of one transistor. That's the second. That's third. That's fourth. So the control board is just sending some signals and it's switching the driving transformer on and off. And because we have 2 windings on the secondary side of the transformer, so when one pair is on, the other pair must be off, and opposite. After the transistor, we have the transformer. After the transformer, we have diodes, what are screwed to the bottom of the radiator. Of course, the position of the diodes or all the parts can be different on different welders. We can't see the diodes because they're right in the back and under the radiator, but basically if you're gonna check the PCB, you will see straight away where the diodes are. In this case I have only 2 pins on the diodes, on each diode. Usually that's 3 pins, and usually that's double diodes. So basically you have 3 legs, and 1 leg is connected to the main field on the PCB, and 2 others are connected on other side. Let's test the transistors and let's test the diodes. Of course we have to just change the multimeter for diodes, and using these two probes we can check every single diode. This shows around 0.4 volts. That means the voltage drop on the diode is 0.4 volts, and that's absolutely fine. Of course that can be different from different diodes, but it must be between 0.2 to 1 volt. Because the diodes are connected in parallel, if one is faulty, you will see the bad readings on the other ones as well. So as you've seen on the diagram, we have two sections of the diodes. Here's the one, here's another one. So actually if we have one faulty diode here, we will have the bad readings on the other one as well. So to check which one is faulty, and usually all of them will be faulty, but to check this we have to desolder the diodes and check them. The next thing to test, that's the transistors. We have 4 transistors here. The first thing, we shouldn't test the transistors on the PCB, because there is a few other elements connected to transistors. So we're just looking for drain and source of the transistors. So basically we can see for this leg there's some resistors and the Zener diode connected. So that's mean this is the gate, so this is the control pin. So we're just testing the other two. And we have some voltage drop because inside the transistor there's a diode. So this one looks alright, but if we're gonna test this on the other side, you will see some strange readings. That's because we have some capacitors connected with these pins. So basically now we're just charging the capacitors, and if we're gonna swap the probes again, we're gonna discharge the capacitors, and that's gonna go almost to 0, and it goes up to the drop voltage on the diode. But this is absolutely normal, so this transistor is okay. What we're looking for shortages, and that's gonna be usually a 0 volts. So we can test all of them, but of course, you know, on my welder that was not the issue, so I don't gonna test all of them. Of course, there's many more components on the PCB. There's some more transistors, small transistors, driving transistors. We have some even the spark gap over there, what is actually for TIG welder when you're just finishing, and if you're gonna pull the torch from a metal, it will just create a spark here. We have some current sensing donut. So basically this is checking our amperage on the output, and is just setting the duty cycle on our transistors to get the correct current. The most important things, that's the power supply, the transistors and diodes. Some tips how to find the problem. Usually there's a few things what goes wrong with welders. In this case there was a power supply, but yeah, this is quite unusual. In most of the cases the main transistors are gone. If the main transistor is gone, that can be a few reasons. Maybe the welder was working in the duty cycle more as was designed for, or maybe there was a basically faulty control circuit, and basically the two transistors being switched on in the same time. But when the transistors are gone, usually the few other components is gone as well. If there was a shortage between drain and source, that's not a big problem because they will trip the whole electric. But if there was a shortage between gate and the source or gate or drain, then probably the other components on the gate side are gone as well. There's only few because the driving transformer is just isolating the whole control board from the main board, from the main transistors. So the control board is usually fine. There is of course some problems with the capacitors. If the welder is completely dead, there is a big chance that this small auxiliary transformer is not working. This one is just creating the whole voltage to the control board. So if this one doesn't work, the welder will be completely dead. Sometimes it's quite easy fix because this transformer is controlled by this little chip, and this chip needs some electronic elements to start up. The one is a startup resistor, what is probably one of them, but the main thing is this is this little capacitor here, and this is the capacitor what actually must be charged to start up the chip, and then the chip will start the little auxiliary transformer. So if this capacitor is faulty, it won't work. So this can be a simple fix. If you don't have the ESR meter for capacitors, then you basically can't test the capacitor. So if you don't have the meter to do a proper test, then it's probably better to replace anyway for brand new. When you have no shortage on the plug, on the input, and the welder doesn't start at all, then you might have a few problems on the power supply section or on the control board, because the control board must get the power first to start everything else. Next thing, if the welder starts but you have no voltage on the output, so basically the welder is not welding, is not working, then you might have some problems with the diodes or with the transistors. So check them first. With the transistors, there may be some more elements what you need to replace. You must check every single component before you restart it. Otherwise you may blow the quite expensive transistors or diodes again. So good luck. So here's the welder connected to my socket with the display. Let's see how much current it takes normally on the start and on the running without load. There you go. So you can see normally it takes about 300 milliamps. So that's the normal operation current. Let's start again and let's see how much it takes on the start. Not much more, it goes up to about 600 milliamps. So that's absolutely fine. Okay, so the new varistor is in place, so time to put everything together, and the welder is done. Thank you for watching, see you in the next one.